Balancing chemical equations, section 2.7. This section, what we're going to be doing is we're going to be finishing what we started in last section. We're going to be able to take those word equations, and we're now going to be able to make sure that they are the same on both sides to balance out all atoms. So to be able to do this, we have to think about the law of conservation of mass or the law of conservation of matter. It's the same thing. And we should know this already, that whatever we start with, we end with. And so we have to have the same mass when we start our reaction and when we end our reaction. Again, law of conservation of matter or mass, it is the same thing. So how does this lead to balancing? Well, matter can't be created or destroyed during a physical or chemical change. So what happens is the matter that's on the reactant side has to end up on the product side. So what happens? We have to make sure the number of each type of atom are the same on both sides, and that's why we have to balance equations to prove the law of conservation of mass. So how do we do this? Well, if we have something like H2O2, if we go back and remember these are both diatomic molecules, hydrogen plus oxygen, so it has to be H2 plus O2, gives us water. Well, if we look, we have two hydrogen atoms here, two oxygen atoms here. When we come over here, there's only two hydrogen and one oxygen, so that's not the same. What we have to do is look at these, what are called coefficients, here and here, to help us make the number the same on each side. So if we put a 2 in front here, we're taking 2 times the 2 that we already have because we have 2 of this whole diatomic molecule. So we have 4 hydrogen atoms. Over here then we've done the same. We put a 2 in front, so we have 2 times 2, which gives us 4 hydrogen atoms over here. Then our oxygen, we have O2 here, so we have 2 oxygen atoms here, but only 1 here. That's why we had to add the 2 coefficient in front here. So the 2 gives us 2 oxygen. So now we have the same number of atoms on each side of our equation. The little numbers are subscripts, or how many atoms we have in that compound. Again, the big numbers are coefficients. The coefficient goes with the whole compound, so we have 2 of this whole water compound. Subscripts balance the charges, so these little numbers are what balance the charges. The coefficients are what help us equal out the number of atoms. So what do they really mean? Well, if we look at this formula equation right here and we draw it out into diagrams, we can see that we have methane. You can see that there's 1 carbon with 4 hydrogen. If we have 2 O2s, that means we have 2 oxygens with 2 of them connected together in that diatomic molecule. We have a CO2, a C in the middle with 2 oxygens, and then if we have 2 waters, we have 2 water molecules. So our coefficients then balance out this equation. We can see if we count up these circles here, these atoms, we have 1 carbon, 4 hydrogen, and 4 oxygen. If we look at our products, we have to have the same. We have to have conservation of mass. So we have 1 carbon here, we have 1, 2, 3, 4 oxygens here, and 1, 2, 3, 4 hydrogens here. So you can see that we have the same number of atoms on each side of our balanced equation. So how do we balance? There's a couple different ways. I'm going to go through balancing by inspection. Some of you will like this method. Some of you will just be able to look at this equation right here and be able to put a 2 here and a 2 here and balance out the equation. If you can't look at it and do that, then you'll want to follow these steps. You'll want to write down your reactants and your products. So you can see on the reactants there's carbon, hydrogen, and oxygen. So there has to be carbon, oxygen, and hydrogen then for your products. Next thing we do is we figure out how many we have of each element on each side. So if we look at our carbon on the reactant side here, we have 1 carbon. We would write that in. We would look at our hydrogen, look at our product, and we have 1 carbon on that side. Then we would look at our hydrogen. We have 4 hydrogen on the reactant side, and we have 2 hydrogens on the product side. Then we would look at our oxygen, 2 on the reactant side, and we have 3 on the product side. So now we have to figure out how to balance those and make those even. So our third step is adding coefficients to balance those numbers. We know that our carbon is fine. It's equal on both sides because there's a 1 in each box. If we add a 2 here on the product side, 2 times 2 is going to give us 4, which is what we have over here, so that would balance out our hydrogens. So now we have 4 hydrogens on each side, but what you also have to do is take the 2 times the oxygen. So now we have 2 oxygen here because there's a coefficient in front of it. We also have 2 oxygens here, so that gives us 4 oxygens. This side we only have 2 oxygens, so we have to balance that out by putting a 2 for our coefficient there to get a total of 4 oxygen altogether. And then that's our last step. We would put a 1 in for anything that's not balanced out.